want to talk to you a little bit about how to decide if a function is a linear function or not. And so um, got a couple of examples, and this is just the beginnings of trying to figure out if a function is linear. We'll have other strategies that I introduce you to later. Right now we've got an input of x and an output of y in this table. And what I want to look at is I want to ask myself, does this relation have a constant rate of change? So as I increase my input by 1, I'm increasing my output by 5. So the jump from 1 to 2 here gives me a jump of 5 on my output side. And if I go from 2 to 3, that's an increase of 1 again. And if I go from 15 to 20, that's an increase of 5. So that stayed consistent. From 3 to 4, I have an increase of 1. And from 20 to 25, I have an increase of 5. Again, that stayed consistent. So we would say, yes, this is linear. It's linear because it has a constant rate of change. If something has a constant rate of change, when I go to graph it, it should form a nice straight line. So let's check that. If I go, if my x value is 1 and my y value is 10, I'll have a point right about here. And then 2 and 15 over 2 up 15. And 3 and 20 over 3 up 20. And then 4 and 25 over 4 up 25. And so as you can see, the points line up in a nice straight line. And in fact, if I wanted to know the slope of that line, the slope of the line is 5. It's the same as the constant rate of change because every time I go over 1, I'm going up 5. So my vertical change is 5 every time my horizontal change is 1. So I have a slope of positive 5. So this is linear and it makes a line and there is a constant rate of change. Let's look at another example. I made this table just slightly differently in this horizontal fashion. And I'm going to look for the same thing in this relation. I want to know, is there a constant rate of change? So as my input increases by 1 here, my output here has increased by 4. And as my input increases by 1 here, my output, it increases by 8. To go from 8 to 16, that's 8. And so I can actually stop there because I can say this is not linear, or we would say non-linear. Non-linear because there's not a constant rate of change. If I went one more time, I would see that this is plus 1 and this would be plus 16. And some of you might be saying, well, there is a pattern there. That there absolutely is a pattern there. However, that is not a constant rate of change. The change keeps changing, so this is not constant. When I graph it, it shouldn't look like a line. So let's take a look. If I go over 1 up 4, I'm going to have to estimate a little bit here, right about there. If I go over 2 and up 8, that might be right about there. If I go over 3 and up 16, that would be right about there. And if I go over 4 up 32, that'll take me just above there. And so if you look at this, this is more of a curve here as opposed to a straight line. And you will study eventually in math this type of function. But right now what I want to notice, and I might even sketch this in a little bit so you can definitely see that that is not a straight line. It's more of a curve. So this is non-linear.